talk about systems of quadratic equations. So systems of quadratic equations are really similar to systems of linear equations as far as solution techniques are concerned. You can use substitution or elimination, whatever you want to do. So let's say we have something like y equals x squared plus 5, and also y equals x squared plus 2x plus 3, something like that. So how do we solve this system? Well, one way is just to subtract the equations from each other, and we get 0 equals, well, the x, not only do the y's cancel, but the x squareds cancel. Then we get minus 2x, and then 5 minus 3 is 2, plus 2. So 2x equals 2, so x equals 1. So that's one way. Or we can substitute. We can substitute this stuff in for that y there. We can do x squared plus 2x plus 3 equals x squared plus 5. And then if we minus x squared from both sides, we get 2x plus 3 equals 5. Then 2x equals 2, x equals 1. Either way, we get to the same answer, x equals 1, and we could plug that back in to find our y. We could do y equals 1 squared plus 5 equals 6, or we could do y equals 1 plus 2 plus 3, which also comes out to 6. Either equation works out. So the solution here is 1, 6. Sometimes the x squareds won't cancel, though, in which case you'll have to solve another quadratic equation. So something like y equals 2x squared minus 8x plus 3, and y equals x squared minus 2x. Well, so why don't we substitute this? So we can do x squared minus 2x equals 2x squared minus 8x plus 3. And if we subtract our x squared over, we get negative 2x equals x squared minus 8x plus 3. Add 2x to both sides, we get 0 equals x squared minus 6x plus 3. And we can try to factor this, but it's not going to work out. So we'll have to use the quadratic equation, and so negative b is 6, plus or minus square root of b squared is 36, minus 4ac, so it's minus 4 times 1 times 12, minus 12, over 2, a as 1, so just 2. So yeah, you simplify this, equals 6 plus or minus root 24 over 2 equals yada yada yada. And then you find what your x is, and you plug it back in. Now keep in mind you have two solutions, so to find the y for each, you'll have to consider the 6 plus root 24 over 2, plug that back in, and you'll also have to consider the 6 minus root 24 over 2, and plug that one in as well. Let's just build some, let's build some graphical intuition behind what the solutions look like. So when you've got systems of parabolas, then maybe you have two parabolas that intersect at this one point. Maybe they don't intersect elsewhere. Or maybe you've got two parabolas that intersect at 2 points. Maybe there's one that goes like this, and then another goes like this. Or maybe there's one that goes like this, and then another goes like this. Can we find one that intersects at only one point? Or, oh yeah, we already have one that intersects at only one point. Well, another one that intersects at only one point could be something like this. How about something that intersects at 0 points? Well, something like this and this could intersect at 0 points, or something like this and this. Something that intersects at infinitely many points? Well, something like just the same parabola on top of itself. So we've enumerated all the possibilities there. You're either going to have 0, 1, 2, or infinitely many solutions. These are all the possibilities. So if you find yourself getting 3 solutions for a system of quadratic equations that only has this 2 equations in the system, then you might want to double check that you've done everything right, because we can only get 1, 2, or infinitely many solutions.